All right, so let's have a go with what we've got. So this was going to be a fairly demo-heavy presentation. Fortunately, I have actually got some code snippets from the demo in the slides, so hopefully we should be able to at least talk about the sort of things that I was going to do. So if we can switch over to my laptop later on, then we will, but if we can't, then we'll make do. So, my name's Mike. It's my colleague Ondrej. We're both here from Payara. We both work in the support team there, and this talk is titled "Baking a Java EE8 MicroPie." It's had to change a little bit from that due to completely different hardware issues before we even got here. So it's not been a good talk for hardware gremlins. But effectively what this is about is putting Java EE8 and Java EE in general into context. So obviously, given that Java EE8 has just been released, there's going to be tons of talks at Java 1 that are going to go into all the specs, that are going to tell you all about how they work. So although I will be touching on that, that's not the core motivation for this talk. The core thing that I'm looking to do here is provide a little bit of context, show you kind of where Java EE8 is now, where it's been, and kind of how it relates to the world that we're in currently. Yeah, so let's get started. So just a little bit about me and Ondrej. So I am a Payara support team member. That's my Twitter handle if you want to follow me. And I'm a snowboarder, and there's my proof that is a genuine photo of me, but it is made to look much better than it actually is. So Ondrej is also Payara support. That's him on Twitter, and he's a dad, and obviously doesn't have much time for anything actually exciting anymore since that happened. So, what's this all about then? So, the key thing that I want to talk about to begin with is how lightweight Java EE really is. So Java EE, traditionally, I mean, you'll all know, has had lots and lots of criticism about how it's heavyweight, it's bloated, it's bulky, it's all difficult to work with. I think, to be honest, I think in general the tide is turning on that sort of opinion. More and more people are using modern Java EE and finding out that it's completely different to how it used to be. So I don't want to labour that point too much, but just kind of investigate what makes it lightweight. Why is it easy to get up and running with? Then I'm going to look at what's in Java EE8 today, what's been released, and what kind of things can you use. And so this last point has been heavily modified. So obviously we've just recently found out that Java EE is moving to the Eclipse Foundation, and then it was announced that project was going to be named EE for J, Eclipse Enterprise for Java. But then also there's been a recent clarification from Mike Belinkovich from Eclipse to say that although EE for J is the umbrella project name, it's not necessarily going to be the replacement branding for Java EE. So I had to modify it a third time because we don't know what the name for it is going to be. We know that it's probably not going to be Java EE due to trademark things. But yeah, there's a lot of reasons to be very excited about the future of Java EE, whatever it becomes. And I'll touch on that a little bit. We'll also, depending on how the demo works, hopefully get a chance to look at that as well. So, I'm going to kick off with a bit of recent history. So kind of around this time, sort of 4 years ago, we had Java EE7 just out the door with Glassfish 4. I remember because I wasn't a Java 1, but I was back in the office blogging about it and trying to get everyone excited about the new Java EE7 release. And as I was preparing this presentation, I was thinking a lot about the general landscape that we've got at the moment, the servers that we've got available, how things have been changing. There's been a lot of changes actually just in recent months. But trying to think back to when Glassfish 4 first came out, actually it's quite difficult. So I went Googling, I went to have a look at where things were, where key technologies were. And what I found actually kind of surprised me how far we've come in such a short time. So the first thing was Docker at this point was just 3 months old. So Linux containers obviously were a thing, and people were aware of them, people were starting to use them, but Docker was really, really new. So at the point when Java E7 was released, this whole, brave new world of containers and, shipping absolutely everything in just one nice, neat little box that your operations team can't mess with, that was completely out of the heads of most people. Wasn't really on the roadmap. Wildfly, it's one of Payara's competitors. That didn't exist in a named format. It was still JBoss AS, the open source version of JBoss. So I've put, it was before Spring Boot. Actually, at that date, you can check on GitHub, because that's how I found out. There was lots of tags, sort of pre-release tags of Spring Boot, so it was being very actively developed at that point. But I didn't go into the details of what features they got in there yet, but it was still very, very early days and quite far away from its version 1. WebSphere Liberty Profile in June 2013 had recently been released. So this actually wasn't long after I had left IBM. So I used to work for IBM a little bit before this. So I kind of saw a little bit of the background of Liberty being created, and that was something that I was quite interested in. But at that point, it was still very, very early. It was just implementing actually the Java EE6 specifications. It was quite far away from doing any Java EE7 stuff. It took it quite a while to adapt to those. And a lot of the features that are in WebSphere Liberty now were not in the Liberty profile as it was. So, bring us forward to 4 years later, we're now at a stage where Java EE8 has been released. And obviously in that time, Docker is now the dominant container format. So it's gone from completely brand new and a lot of people being a little bit skeptical about it. It's gone through the traditional hype curve, and to be honest, there's not really been the massive trough of disillusionment of most things yet. But when you look at competitors to Docker, like CoreOS, who do their own container format, even they, in their engines, will support Docker's container format. So it might still be a little bit early to call it, but it does seem like Docker has probably won on the container format wars before they even started, really. But that has actually introduced quite a seismic shift in just the way that we deploy things in general. When you look at the really key technologies in cloud computing at the moment, we've got Kubernetes, which has got Docker at its heart, and lots of other things which only really exist because of what Docker has done. That's why I've included a non-Java technology there. So Wildfly, for a start, has become Wildfly. I put down that they've fully productized Swarm. So Swarm is their composable Java EE application server. So if you've not used it before, you can define fractions in Swarm, which are really small kind of components, maybe just like CDI and JAX-RS and nothing else. They've got a MicroProfile fraction as well. I haven't said they've released it because I'm not sure how they stand on support. So I know that Wildfly is their unsupported, innovation stream. It is now into a proper product. I remember when it first came out, it really did seem to me, and probably to quite a lot of other people, as a bit of a hobby project. It was quite good when it worked. It was quite easy to get wrong and break, and quite hard to find out where it broke. But quite quickly, Red Hat have put a lot of effort into that and made it into a really, really good product, a good competitor for us. Obviously, Spring Boot have been making their jars, not wars, as Josh Long loves to say, for quite a few years now. And I think the key thing there really is that they were really the ones to kick off the current kind of fat jar movement, if you like. So it's really popular, I think, mainly, or the key benefit that I see is that you keep all of your configuration within one WAR file, within one distributable. So rather than having your application, which you can deploy to an application server, but then it won't run because you also need to get some configuration in the application server, that's Not an issue with Spring Boot because it's all just packaged together, which is nice. IBM have released OpenLiberty. So everyone noticed that happened fairly recently? If you don't, IBM have obviously got a booth at the exhibition center. You can go and find out about that. I know a lot of the guys there are quite keen to chat about that. So OpenLiberty is, so I remember when WebSphere Liberty was the main thing, they were saying that I think about 40% of the server was open source. So they've open sourced a lot more of the server. It's not quite all of WebSphere Liberty. So there are a few things that are left out of that. So for instance, the admin console that they've got is not in the open source version. But what is in there is all of the Java EE specifications and all of the MicroProfile specifications that they've pushed out. So as developers who want to write applications to run on a server and just want something to run stuff, that's a really great option now. And of course, that's us. So obviously we didn't exist 4 years ago, but since then we've seen that Glassfish is no longer commercially supported. Payara has brought in Payara Server, and we've also introduced Payara Micro, which we'll be talking about today. And finally, we've got the Eclipse MicroProfile. Just a show of hands, who's not heard of MicroProfile? Okay, so a few people haven't heard of it. Okay, so I'll give you a bit of background about what MicroProfile actually is then. So it all kind of starts back last year around June, and it's been really a collaboration between Red Hat, IBM, us in Payara, Tommy Tribe, and a few of the Java community groups like the London Java community and SuJava in Brazil. And effectively what it is just, it's a response to the question that often gets thrown at Java EE about innovation. So Java EE, you might well know, by design, goes slowly. It doesn't want to kind of push forward and try and standardize on something before it's a well-respected technology, because it has to be backwards compatible and it's got all these different kind of business requirements. So because obviously there's that restriction of Java EE and we don't want to kind of break that, all of the guys involved in MicroProfile, and we at Payara were quite involved with that, decided that what we need really is a new place where we can kind of sandbox new technologies that react to what's actually going on out in the real world, get some quick feedback from you guys developers who want to use this kind of thing and these APIs, and then hopefully use that as a way to kind of push forward into Java EE. Obviously it was announced as an initiative in June last year. We announced MicroProfile 1.0, which was really just a starting point based on Java EE 7 APIs, just CDI, JAX-RS, and JSONP, just last year at Java 1. Now, the reason why we only went for those was because we wanted to strip it right back to the absolute bare minimum that you would need to write a microservice-style application in today's world. So we accept that you would likely have to add stuff extra on top of it. We wanted to start with as little as possible so that we didn't add too much extra cruft that we regretted down the line. That's progressed quite a lot since then. So we've released 1.1. I think 1.2 has that been released now?
It's released, not yet announced.
Okay, so it's sort of released for 1.2. I think there still needs to be a few extra things need to be tied off before we properly announce it. But we've got an API for configuration, which I'll actually show a little bit in this slide deck. We've got an API in 1.2 for metrics, for health checks, for JWT token propagation, and I think I covered everything. I think that's everything. There's been an update to the config API as well, and fault tolerance. Yes, we've got an API for fault tolerance in microservices as well. So, what's in Java EE 8? Again, obviously I didn't want to kind of completely ignore all the stuff that's in it. So we've got a few things that have been upgrades. JAX-RS has now got a reactive client in it. So it's had a client for quite a while, but there's now reactive APIs to work with that. There's also server-sent events in JAX-RS, which I think have been out in or standardized in kind of the non-Java sphere for quite a while. So now we've got standard in JAX-RS. Servlet 4, which I think is actually one of the really, really major things in this release. I know Servlet is a very old technology, but that now supports HTTP 2. If you thinking, well, that's fine, HTTP 2, why is that a big thing? You really need to look into it. I really think that's going to be a major, major thing over the next few years, particularly with the speed improvements it brings and the security by default that it brings. You can't run HTTP 2 without being secure. I could talk a little bit about that later, but I don't want to labor that too much. Bean Validation 2.0 is out. It's got quite a few updates in that. Same with JSF. I don't think there's any individual thing that's too major in JSF. I know it does support WebSockets now natively, so you don't have to add in your own framework like Atmosphere or something. It's all native. CDI 2 brings asynchronous events, and JSONP brings a few kind of minor additions. I think like merge patch and JSON pointer. Just to close off a few things that we're missing really from the first spec. New specs, we've got Java EE Security, which is kind of based on JASPIC. I don't know, Ondrej, you'll probably be able to speak about that a bit more. Do you want to?
Yes, I can, but I think...
The microphone should be on there.
Yeah.
Can you hear me?
I can come over for this one. So.
The thing is with security, it's a crucial component of Java EE and business applications, but it was traditionally hard to set up security and was divided between the application and the application server. So traditionally specify how user's credentials are authorized, how the user is authenticated, and given the roles is specified in the server, and the application only consumes this information and specifies required roles, but it can't or it couldn't influence how the user is authenticated and authorized. And there was an addition, I think even Java EE 6 supported this. There's a specification called JASPIC, which provides a way how to plug in your authorization mechanism from application. But there are two main problems. One obvious problem is that very few people know about it, as there are other specifications in Java EE which are also less known, and this is probably the least known specification. And the other point why it also isn't so widely adopted and known is that it's very complicated. It has like 3 different interfaces, but you need to combine together. And if I would compare it to the new Java Security API, it's like EJB2 and EJB3. So the JASPIC was really complex to work with, and the new Security API is based on a CDI, and only with a few annotations you can specify your own pluggable module, which you can put into your application. So you can control authentication and authorization from within your application, and you no longer need to depend on the configuration provided by the application server. So the simplicity was in mind there.
Thanks, Ondrej. Yeah, it's always great to have someone else who actually knows what they're talking about to give some extra details. So yeah, I think that kind of ties into what we saw on the previous slide about how the Java EE landscape has changed and how we've got Spring Boot and actually Waffle Swarm and Payara Micro, all which allow you to add configuration for your application server into the deployment artifact. So again, like Java EE Security has kind of enabled a big thing about that as well. JSONP is obviously I always think there's a bit of a danger of seeing JSONP as quite a minor thing. I think it's actually much more significant than people might think. Certainly from using it in the demo, which I hope we'll be able to actually look at, it was quite significant, and I think it's a big help. It's a lot of convenience annotations, but it will make life a lot easier. When we get to the demo, hopefully we will, we're going to be running this on Payara Micro. So I just wanted to, for the benefit of people who may not know about Payara Micro and what that is, go over a little bit about what's actually in it and what we do with it. So it's a downloadable jar artifact. It's just 60 megabytes-ish. I think it always tends to come up around 60 megabytes. It's kind of varies a little bit from release to release. But it's dynamically scalable. So at its heart, it's got Hazelcast. And obviously, Hazelcast is really good at dynamically clustering with other different environments. So you stand up one Payara Micro, just use jar-jar, payara-micro.jar, and then you stand up another one. They will automatically discover and cluster each other without any extra effort on your part. And obviously, because we're based on Hazelcast, we've got all of the different kind of Hazelcast plugins for things like AWS deployments. So it's got native discovery of other instances that run on AWS. It can do it over TCP or over multicast. It can use Kubernetes, Azure as well. I think there's a few other different discovery methods as well that can be added through plugins. It's fully embeddable, so you can just embed it to your application. We call it Web Profile Plus because it provides, or it will support all the same APIs as the Java Web Profile, but one or two extra ones as well that have been added in. And it's on Maven Central there. So I'm not sure if that beta 1 snapshot is actually up yet. It was supposed to be up around about now. I haven't actually been in touch with our developers to see if it's been released yet, but there is definitely an Alpha 2 snapshot, which is on the Maven snapshots repository. So they're just the key APIs. I won't go through them all, but we can see that that's all basically the web profile, except for we've added JBatch, we've added concurrency, and JCache, which obviously isn't a Java API yet. It's still a candidate to be one. I think it should be, but it's doesn't seem to be moving forward, although the spec itself is still evolving. We've also quite recently added JCA to this, so that's not been possible with web profile before. What that enables you to do is use it as a JMS client, which I think is a really important thing for cloud-native deployments. But also it's meant that we can create our own resource archives for working with modern messaging communication tools like MQTT, Apache Kafka, Amazon's SQS service. We actually got a repository in GitHub called our Cloud Connectors repository, where we've got examples of all of those. And I have to say, it is very simple to use. You just kind of create a new MDB, use all the same activation config property annotations to set up your location for your MQTT broker. And you can subscribe to messages just with normal MDB stuff. So your EJB pool configurations can be used to control that. The other thing is config. That's the MicroProfile config API, and that's been added for a little while now. I think we've certainly got a few extra updates for config 1.1, and I think that's due out in November-ish time in our next release. So that leads us on to the demo, which is I need to switch over to the laptops. Is that going to happen? Can we get that sorted? Number 5. Let's just make sure I've got the. It should be number 5. If we're lucky. Great. You got something up? Nope.
There you go. No, that's not it.
That's that one.
Is that one plugged in?
So we'll have a go and see if we can get everything up and running. If not, then I can just talk you through things, I guess.
Maybe you could describe.
Maybe on the left it said the duplicate is variable.
Yeah, so that's the issue, is that it's not detecting any input. It did first thing this morning, but yeah, since not been able to get it since.
You just can't get it out of your laptop.
Okay.
So I guess we can't do it, sorry.
All right then. Okay, so let's ignore the demo then. So let's go back to.
Maybe I could get it running on my browser. I've got HDMI.
I don't know, it might take a bit of a while to check everything out and everything. Okay, so let's show you what the demo was. So it was going to be running on my little Raspberry Pi cluster there. So the cluster itself is, just for the benefit of any hardware hackers in the room, just a Raspberry Pi 3 on the bottom, the red board on the top. So it's kind of, it looks like it's plugged into itself. It's not. That's just transferring power from the main board. That is just a board which kind of supports power for the 4 Raspberry Pi Zeros on top, which allows it to cluster together, which worked beautifully back at home, and then I killed it. Because the problem with it is it's all coming through a single power source, and the issue with that is that when you've got all 4 of them running at once, plus the main board, there's not a lot of power to go around, and it just slows down a lot. So I tried to increase the power, and yeah, don't mess around with power and things like that when you don't know what you're doing. So the demo scenario was going to be all about stock. It's based on an application that we'd already got, like a StockTicker demo, where we'd had a couple of Raspberry Pis. We stand up Payara Micro on one, which has got a StockTicker in it, and we stand up Payara Micro in a second one, which has got a web application. And we use an EJB timer to fire events over CDI, which then, because we've got Hazelcast to cluster these two together, rather than these events living just within the first JVM, these can be sent over the network to the other JVM and be processed by another member of the node, which is quite a neat API that we've got in Payara Micro. It's the same CDI events API that you would normally use, but we just annotate that with @outbound. So that's roughly what it was going to be. So we've got stock tickers at the bottom, and we've also got another feature in Payara, which allows you to have clustered singletons. This basically means that across the entire cluster, you can stand up the same microservice that you want, but you can guarantee that across the entire cluster, there will only ever be one instance of that, either EJB or, I don't think it's actually completely featured yet, but soon to be a clustered scoped CDI bean. So yes, the stock ticker has an EJB timer in it, which is a singleton that will produce events. The stock web, obviously being clustered together, will receive those events and push them through WebSockets to a browser so they can be consumed. So I might have to skip through a little bit about the things that we were going to show. But effectively, what I would have shown, I mean, actually all this is on GitHub, so I could just see if I can get that up. I'll at least be able to talk about the code a bit, which is better than nothing. Great. So first thing is the stock object. So this is StockLib. Hopefully this has got the. Is that a little bit better? You can see it all. Yes, it looks like it's all at the right version, which is good. So actually this is going to have all of the kind of finished final stuff. So I was going to kind of run through it and write all the code for this, but we can just look at the end product here. So what we've got is just a normal stock object. You can see I've added JSONP annotations already, but I'll talk about those later. So all we've got in our stock object is a symbol, a description, and a price. So the symbol, obviously, every stock needs to have a symbol that it identifies itself with, which needs to be unique. Price, now this is just a random double, and a description, which is a string. So to begin with, I created a to JSON method, which obviously just serialized it to a JSON object for me, and then had a string which just toString method which just called that, and then a toString on the JSON object that was returned. So this was the kind of the old Java 7 way of doing things with the JSONP API. So it's quite functional. I mean, there's not a lot there that's really difficult or hard to use, or but it is quite manual. So kind of creating all this stuff involves a lot of extra work from us. So go back to the thing. So the other thing that we need once we've got our stock object is the StockTicker to actually set the stock price. So we've obviously the object is just there. It's not doing anything at the moment. So yes, here we can see that we've got a StockTicker. All it is just a singleton EJB with an EJB timer there, which is scheduled for every second. You can see at the top I've added the clustered annotation there, which is Payara micro annotation, just to ensure a single instance across the entire cluster. No, probably. Yeah, it's probably a bit better. Yeah, so we've got this event here that I've created here. I've annotated with at inject and at outbound. So the outbound annotation effectively tells the clustered CDI Event Bus that these events need to go across the network to anything else that's clustered and that's listening on them. You can see that in the brackets here I've also added loopback equals true. Now the reason for that is that if you want to process the events within the same JVM as well as over the network, then we add the loopback so that it sends it to itself as well. We don't do that by default. And here obviously in the timer we're just kind of creating a new generic instance of stock with just a math.random for the actual stock price, which obviously means that the yep.
So every node in the cluster will get the event, is that right?
Every node, yes. So what we can actually also do is that there's another thing that we can do in the brackets there is add a name to the event. And then when you add your at inbound annotation, you can specify that you only want to listen to a certain name. So it effectively works. It's not quite a topic style of thing, but it's effectively doing the same sort of thing.
And so, right, like CDI events, you filter by object class, the class type.
Yes. So Ondrej just pointing out that, like with CDI events, you kind of filter by the object class type. Yeah. Okay, so we've got the StockTicker that set the stock price, and we've got a publisher for the CDI Event Bus. So for the StockWeb listener, what we're doing is creating a WebSocket endpoint, which is just the standard API that's been around in Java 7. So at this point in the demo, all we're using is just Java 7 stuff and existing technologies. So we're going to kind of start there and then add on the Java 8 stuff later. So we need a class to manage the WebSocket sessions. And then for each session that's registered, we're going to kind of push things out via the on message, I think. and then a class to listen for the stock events on the CDI Event Bus. So first we've got the session manager, which is an application scoped CDI bean. And we inject the CDI event bus itself. So this is how we actually receive the events that we've got. We've got a register session, deregister session, which is just a hash set. And here we've got an observer method where we've added our @observes @inbound stock. So the only thing that we've really added there is the @inbound, and that's where you put the extra, in the brackets to filter by the name. In the for each loop that we've got there as well, each session that we've got registered, we wait for the event to be received. As soon as it's received, it will send everything out to every subscribed consumer. So all this is kind of fairly basic, just sending the text as a string object. And if I go to here, let's have a look at the actual WebSocket class. So we've got the server endpoint of /graph. We're injecting the session manager that we just created. Got an open method here which registers the session. Then once it's registered, then we let the session manager push out all the data based on the observe method. So that's really all that's going on there. I won't go into the actual JavaScript page because it's just a JavaScript page which has the JavaScript WebSocket endpoints to listen on those. So now there we should be at the point where everything that we've got at the moment, if I was able to run it and show you it working, we would have a single JVM with a StockTicker. Every second that's going to publish events, those are going to be fired out and then received by the other instance, and then that's going to be pushing these things out via WebSockets and via the session manager to the browser. So what the user sees is a nice dynamic graph which just has WebSockets dynamically updating everything. So at the moment that's something that you can do, before today, before Java EE8 came out, and there was nothing particularly new in there. So my first thought for this, like I said at the beginning, I wanted to put Java EE8 into a little bit of context. So I thought that the issue with using the CDI Event Bus, although it's fantastic if you've got like an internal application where you control all of the services to give you your end application, you can use the CDI Event Bus for your internal communications there. You can use it wider than that if you want, but you can't guarantee that someone else who wants to maybe use one of your microservices, or if you want to expose something publicly, you can't obviously guarantee that they're going to be able to consume those sorts of events. So we need something else to handle that. And the solution there was server-sent events from JAX RS. So obviously I did have the WebSockets thing already set up in the stock web. Obviously we could have used that, but the difference there is that WebSockets is binary communication, it's two-way communication. So what you're basically doing is opening up a channel where you not only send data, but you're also waiting to receive data as well. So you've got all these extra endpoints listening for stuff that aren't doing anything, because all we're doing is broadcast. So server-sent events is a perfect chance for this. It's just using REST, it's using standard web technologies that have been around for a long time, and that are specifically designed for broadcast. And so the other thing that I was going to do as well is, again, assuming that we're going to make this thing public for other people to consume, we'll use JSONP to serialize the StockObject and give like a nice a nice kind of stock object which we can then be used easily by other consumers. So this is actually where I've got code in the slides, which makes things a lot easier. So beginning with, we saw this in GitHub already. This was the original way that I was doing things with JSONP. So all we've got is just a JSON object returned by a toJSON method, and then we're just setting that to string, which is fine, but it's a little bit manual and a bit brittle. So these are the things that JSONB brings with it. JSONB.net has got quite a few examples and things and links to the specification. But effectively, we can see down at the bottom there, we've got this.stock equals JSONbuilder.create.fromJSON. And, oh, sorry, that's to deserialize. So the one just above that is the toString method just here. So what we're doing here is we've got JSONB config, which is called nullable config because we're allowing for null values. Here what I've done is just put that in the brackets where I've got .create nullable config. You don't have to have that there. You can do .create with nothing in the brackets, and it will just follow its own default rules to create the JSON, and it will just serialize for you. In the middle there, we've got on our three fields, we've got symbol, which I've just left unannotated. But I've put JSONB transient on the string description. So this is just to demonstrate that we might have like quite a long or quite a heavy data field that we don't want to serialize, or it might be maybe an image or something in your class that you don't want to serialize through JSON. JSONB transient will just set that to be ignored. We've also got a JSONB property there. So again, because this is literally just an EJB timer generating random numbers, and it's a stock ticker, thought it's probably quite good to let people know that this isn't an actual stock price, it is just a random number. So that will just override the actual price, and that will mean that in the JSON object that you get back, that's what gets picked up there. And obviously in the demo, we needed to change our JavaScript class from looking for the .price to looking to .random price, because otherwise that would not be found. So let's move on. So I'm going to ask Ondrej to, again, come up and talk a little bit about the JAX-RS Reactive Client API. So this wasn't something that I actually included in my own demo, but I thought it is actually quite a significant feature of JAX-RS, so I wanted to mention it. Fortunately, Alex Steedham, who is here and doing some of his own talks, do go and catch some if you can. He's a very good speaker. I'm sure his demos always work. He's written this blog post, which is a very good investigation into things, and he goes over a little bit about the Reactive Client API just here. So, if you want to kind of explain what things are happening.
So the Reactive Client API is like improvement of the API that was there already with Java E7, and it was called Asynchronous Client API. And since it was based on the Java 7, it couldn't use completable future and all these new stuff in Java 8, like lambdas. So it provided a more cumbersome API than it can now with Java 8. Previously, with the asynchronous API, you had an option to provide a callback when you sent GET request to the service, and the call wouldn't be blocked, so you can continue doing some other computations in the same thread. And then when the service call was finished, the application server would execute the callback, usually in a different thread, and without blocking your original thread. But this was cumbersome because you needed to provide a callback as an implementation of an interface, and there was no way to simply chain other execution on top of other executions on top of it. So if you just executed another asynchronous call within the callback, you got to spaghetti code, which is referenced as callback hell, because there you have too many brackets nested inside and callbacks nested inside. So with Java 8, there is a new thing, or it's not already, it's not new, but Java 8 brought the completable future as a new thing, which allowed to chain these invocations and to create a readable code while it was still asynchronous. And with the new JAX-RS Reactive API, it's now possible to chain callbacks with completable future, but not only with completable future, but you can plug in your alternative mechanism. For example, RxJava handler, which RxJava is quite popular when writing reactive codes, and JAX-RS natively supports it. So the only thing you need to have is a factory that can turn the result of the service call into an RxJava observer, and then you can use it within the same fluent API of JAX-RS. You don't need to wrap it into a different object. You can just chain the method calls and just change the return value to what you need to work with the library. So that's quite nice. By default, the reactive call would return a completable future, or more precisely, completion stage. But you can override it and have plug in your factory to return a different type. So you can easily chain more computations and turn it into a stream or of invocations. It's not technically a stream of data, because a simple REST call would just wait for the REST call to be finished. Then it can turn it into, or process it into a Java object by parsing JSON or XML, and then you still have the final object in the end. But it makes it easier to write asynchronous code so that your original thread is not blocked. If you want to use real streams with JAX-RS, you would go with the SSE, the server-sent events, which allow to initiate a call, and then the server can send individual events, stream of data as server-sent events, which you can, again, chain with a completable future or callbacks. So that's the new edition of Reactive Client.
Thanks, Ondrej. So yeah, back to the application that we were talking about. So the server-sent events is really the thing that I wanted to talk about here. So I was playing about with server-sent events for this quite a few months ago now, actually. But basically, the JAX-RS specification wasn't finalized at that point. So all I was doing was really just using the Jersey implementation of it, which was kind of where the JAX-RS edition had come from. So we can see here we got this SSE endpoint here. All of this is the Jersey API. This is not JAX-RS. But I wanted to have it here just so that you can compare what it was like to what it is like now. So here you can see that we are returning a type of event output. We've annotated it with producer of SSE feature.server-sent events. Obviously now we've got a proper media type enum that we can produce. So we needed to create a new thread and do everything in that separate thread. I mean, nothing in there is particularly complicated, but it's a lot of extra code to write and just a lot of extra chance for bugs. So just to compare that with the JAX-RS code, really it doesn't need to be as complex as that even. It can be as simple as just SSE broadcast.broadcast that you can see down the bottom there. So the reason why we've got two methods is that there is a get endpoint, which can receive a client request as an SSE event sync. Now this event sync is just something that you can register in your broadcaster, so that then the second method is where we actually broadcast events. So because we've actually also annotated the second method there with @post, it means that you can not only call this broadcast method from within the same class, within the same application, you can have like a separate microservice that sends something to be then broadcast by a separate microservice to all of its consumers. So you can see at the top there, the first one that I've got is the event output one. There's actually 2 lines there. The first isn't necessary, but it's an example of how you can just send a single event. So you can use that kind of API there. But the SSE broadcaster, I think, is the really useful one for the purposes that we want. Now, the next thing to think about is, from an architectural standpoint, is where do you plug this into the application? See, at the moment, I've already got CDI events, clustered CDI events between the StockTicker and the StockWeb services. And then I've got WebSockets at the front end. So what we could do is replace the WebSockets on the front end. So we've still got a CDI event bus between the StockTicker and the StockWeb. And then it's just the JavaScript SSE client that we have to we have to create, basically. I mean, the changes between those, unfortunately, I haven't got those on slides, but they are minimal. It's not much to do that. But when we spoke a little bit earlier about the way that we manage these things, the other option that we've got is the JSONP SSE client. And really the decision here is where you want to orchestrate our microservices. If we've got a more complex scenario with this, where you've got a particular function or process that you want to run with several different microservices, I think 5 or 6, would you want to orchestrate that within a JavaScript browser-based application, or would you want to orchestrate it on the back end and then have your JavaScript web page be more of a thin client to it? I would generally prefer to do it the second way, have everything be kind of orchestrated at the back end and then have a thin client at the front, but I know that's not everyone's preference, and either way is possible. So again, have a look at the SSE client code. So from within JAX-RS now, this is the old Jersey method again. We can create a new client builder. It's actually quite similar to the new JAX-RS API, but we're just using different objects and things here. Here we need to actually return the event source, and we're doing creating a new client builder, registering that, and targeting things to a StockTicker URL. So we need to know this URL in advance, which is tricky. We've got a way around that I'll talk about later. The event listener we need to add and then register to the event source. So we just created a new listener. Obviously this was slightly old code, so actually that could be replaced with a Lambda rather than an anonymous method. This is it in JAX-RS 2.1. So I've separated this out into basically 3 different methods. So we've got an EJB that I'm doing a post construct and a pre-destroy on. The post construct initializes everything, so it initializes the client and the web target exactly the same as before. And we're setting the source as an SSE event source rather than just a normal event source, and then just calling the observe method. So in the observe method, this is how we actually consume the event. So we've just got a nice brief Lambda there just to handle all the events that come in. Again, I'm using the JSONP API to deserialize stock events that come in, and providing the throwable print stack trace method reference there for anything that goes wrong, so we don't need to handle that in any more detail. And finally, I just do source.open, and then these events will start to be consumed. At the end there, I've got a destroy method to gracefully close that source so we don't get any errors on the remote side when it just finds the client consumer just disappears. Now this was the, if you wanted to set up JavaScript to do things. So in my particular example, because I'm running this on or I would have been running it on a laptop with everything was local host. You can see that obviously you've got CrossOrigin issues if you're requesting from 2 different ports. So I've got a little diagram there that I got from developer.mozilla.org. And I won't go into that. I mean, this is just a standard response filter for JAX-RS, just adding that single header just to say, yep, it's okay. CrossOrigin requests don't matter. For real, this wouldn't really be a problem because they would always be from the same domain, so we'd know that that was okay. So, really ahead of schedule now. But yeah, so the next thing that I wanted to look at, so we've added a few Java 8 APIs to kind of make things a little bit more generic. What I next wanted to look at was the future of Java EE and where it might go, or EE for J, or whatever it gets called. And effectively because I think a lot of the people that are involved in the microprofile effort have got grand visions that actually microprofile itself is gaining a lot of traction, a lot more than I think than many people expected. I think there is a strong feeling that the future of Java EE, if you want to see it now, look to microprofile. Personally, this is, again, like completely my personal view, I think actually this really is the future of Java EE. Whether microprofile gets subsumed into it or not, I don't know. I hope it doesn't. I think I quite like it as a separate project where it can innovate and it has that extra freedom to just do things that people need. I know that IBM and Red Hat are investing heavily into it. They've got quite a few people working on it. We in Payara are as well as our Tommy tribe. But then also we've got tons of people in the community. So we've got lots of community Apache committers that are putting a lot of time and effort into microprofile. And the whole goal of it is to be really, really community oriented. So anyone who wants to get involved with it can get involved with it. There are stands actually in the exhibition hall downstairs, so you can go and find out a bit more about it and how to get involved. Oh, put some transitions on there. Yeah, so here is the dependency for the 1.1 version, which is the current release. Like I said, 1.2 is imminent. It's basically code complete. At the moment, you need to specify the type is POM and specify that it's provided because it is just an API. There's no actual jar implementation yet. The implementations are provided in the same way that Java EE implementations are by vendors. So those are all the things that you need to do to set our StockTicker URL that we had on our SSE client class. So now the issue that we had there was that we had our JAX-RS client that needed to connect to a URL that it didn't know already, because you don't know where it's going to be until it starts up. If you're in, say, Kubernetes, where the remote server might not be there yet, we don't know. We don't know ahead of time where the endpoint is going to be. It might change, and we need to react to that. So the config API gives us the ability to look for a property that we set in, as far as the API is concerned, 3 places. That's system properties, environment variables, and a file in the, is it the meta INF or web INF for the config property? So there's microprofile. Yeah, so in the meta INF directory of your application, you can create a microprofile.properties file which has all these properties in, and that's a valid config source as well. Each of them has got different ordinal priorities so that you can always know which one is going to be preferred. So we're injecting that, set a default value as well, so that we can handle if it's not there. And that's all you need to do to use it. There at the top, I've given an example of how to actually run everything that we were doing there. So the stock web application, you can see that's a micro bundle. We kind of, in the project, we're kind of building an Uber jar with Payara Micro. But I'm setting the micro.py.stockticker.url property as a system property, and that will be then picked up by the application, which works beautifully if I had a demo. But there's also another option that we've added for Payara Server. Obviously, those of you that are familiar with Glassfish, if you haven't used Payara Server yet, you should definitely check it out. But we've added a few extra AS admin commands to set and get config properties. The reason why I wanted to demonstrate this one here is that we've got the property name and property value are quite clear, but then I've added the source of cluster. So I said that there are 3 default sources for the MicroProfile config API. Those you can rely on for any MicroProfile implementation, whether it's Wildfly Swarm, Liberty, or Tommy, or Payara, that they're reliable. Here, though, we've got a source of cluster. So that means that all those properties are then going to be stored in Hazelcast and then distributed to any other cluster member that joins that cluster at any later point in time. So once that's been set, any other member that joins will get and store that cluster, so that if your initial member goes down, the property is still set and is still available for your application. Which, again, when we're looking at things that are using things like our @clustered annotations, you've got a clustered singleton, that will still be available to that singleton when it starts up later on. So that's quite a neat little convenience method there. So, really, really ahead of time. I hope you've got like 50 minutes of questions. Maybe I'll prepare a talk without a demo next time. So yeah, I just wanted to recap a little bit about what we talked about. And mostly highlight the fact that a huge amount of what I've talked about, aside from the APIs, has actually come between 4 years previous when Java EE 7 was announced to this year when Java EE 8 was announced. All of this has not come from the Java EE specs themselves. It's come from the vendors seeing what's happening in the world around them and reacting to this kind of change. So Java EE is incredibly adaptable, and the vendors themselves that have created these new distributions, like even Spring, which obviously isn't Java EE but does use 1 or 2 Java EE APIs, even their influence is helping to kind of drive things forward. And even though that there was definitely a significant delay in the release of Java EE 8, the industry didn't stop moving, and there's been a lot of change that's been driven by vendors' implementations. And finally, just the Eclipse MicroProfile is, I think, where there's a lot of innovation happening at the moment. There are lots of interesting specs if you are really interested in looking at a microservice deployment. It's really good to look at. If you go down to the exhibition center at any point, I think during the conference, there will be demos of MicroProfile happening there. So that'd be really good to go and check out. And hopefully, I think some of those demos should include some 1.2 specs. But because that is so new, there's not many implementations around just yet. And I think that's everything that I had. Well, it's everything that I had without my laptop. So yeah, sorry that things didn't quite work out as planned. But yeah, are there any questions? We've got a lot of time for them. Yes?
I have 3 questions.
Great.
So you showed the demo of the cluster CDI and the node CDI.
Yes, yes.
But that's very Payara specific.
Yes.
And then you've mentioned that it can be REST-based. But what would be nice if that cluster CDI is actually standardized. I'm not sure if you know if it's maybe on the features of CDI or as a spec on its own.
Well, I know that CDI... sorry? Good. Yes. So I'll repeat the question. So the question was that the clustered CDI Event Bus obviously is very Payara specific, and the question was, do you know if there are any plans to get that to be like a proper standardized feature? I know that CDI 2 brings asynchronous events. Ondrej will know a bit more than me about that, but it's not the same thing now. My gut feeling is that it would be very difficult to standardize on, and the reason for that is that even the JCache specification, which is provided by Hazelcast, does not actually include any clustering, and I think there is not a lot of appetite from people writing specs to include any sort of clustering technology as part of the implementation. So yeah, It would be amazing if it could be. I think it would be such a useful thing to have, but I would be surprised if it does.
Feels like if we are moving towards microservices,
Yes.
we need to start taking seriously.
Absolutely, yes. And it's something that's in Payara, obviously, we're looking for with Payara 5. The intention is to kind of remove the old domain model and go more towards a domain data fabric. So yeah, it is going to be much more like that. I know Vertex, I think, are quite similar in that they use Hazelcast as well. I don't know if they've got any similar kind of technology to the clustered CDI events, but
They don't have CDI.
well, obviously they don't have CDI, but any sort of events thing.
They obviously have messaging, but their type of messaging mechanism is based on sending JSON data so that it can be distributed any kind of language, because Vertex supports not only Java but JavaScript, Groovy and other languages. But they also rely on Hazelcast technology, and like distributed data grids are very interesting because they are quite easy to set up. They're very complex, so you wouldn't want to write them in your application. You'd rather use existing proven solution, but they provide lots of interesting features and they are very easy to use. And to show that, and CDI Event Bus in Payara Micro and Payara Server are a demonstration of how easy it's to integrate Hazelcast to build a solution to distribute messages via CDI. And in fact, the API, which is in Payara, is only 2 annotations. So you can, and these 2 annotations are basically qualifiers in CDI. So even if the implementation is not there, and you run an application that uses CDI Event Bus, you run it on a different application server, you can still plug in your CDI extension or just a CDI observer and plug in your own solution. It can be based on Hazelcast, but you have to create it. Payara Server and Payara Micro have it built in. But if you just use the Payara API, these 2 qualifiers, you just put the dependency on these 2 qualifiers, and then you can plug in your own observer and distribute the messages yourself. It's just Payara makes it easy because it provides this for you. But it demonstrates how easy it is to plug additional things with the help of CDI. The CDI API is very, very easy to use, very straightforward, and very easy to plug into additional extensions.
Yes, I guess, were there anyone else that had questions, or we've got a couple more that we can carry on with, I guess? Yes.
And it's very similar to JSONP.
Yeah.
You know, abstractors and have metadata annotations that describe the closure, and then you have kind of a process of that implementation specific.
Yeah, so I thought that myself. I don't know particularly why that's not happened. I don't know if you are too familiar with it. Personally, I'd like it if that was the case, because I'd like to just be able to serialize straight to YAML, because that'd be really nice.
So now you can also add more ones, and it's already happening with REST under the covers.
Yes, yeah.
These 2 specs should kind of merge into one.
Yeah, I mean, actually, on that point, Ondrej pointed out the other day, which I didn't include in the presentation, that obviously server-sent events has got its own convenience methods for serializing to JSON formats as well. So that there's a lot of this kind of almost like just repeated things in. Yeah.
My opinion is that maybe JSON as a format is a bit different from XML, and JAX-B was specifically designed for XML, and it lacked some support for edge cases in JSON. That's why they created JSONP to support it as a first-class citizen, to support JSON. And some application servers, I'm not sure about Payara server, but some application servers supported JAX-B annotations to convert an object into JSON and back. But this was kind of limited to, if you hit these edge case use cases, it was hard to get the result that you expect. It would work, but if you really wanted to conform to specific format in the JSON serialized data, it was hard to get the names of the fields right. it would just create random fields. But there is obviously no schema for JSON. But if there was, it would be hard to fit the schema and make it valid against the schema. So JAX-B is possible to use, and it was used. It wasn't standard. Normally it was standardized against XML, but some application servers also could use JAX-B annotations to produce JSON and also parse JSON, but it was lacking some features. And since JAX-B is already a part of Java language, not only Java EE, it was much harder to extend JAX-B and add some more features into it than to create a new specification, which is specifically tailored for JSON.
Yeah, I guess another point on that was be just that I think when JSONP was proposed, it was very deliberately limited just to avoid, becoming this kind of huge, sprawling thing that tried to, be everything to everyone. I know there was a decision made to kind of limit it to let's just, do one thing and do it well. Yeah, so ideally I would like to see something that's just, the same annotation and the same thing where you can, just sort of plug in whatever data format that you want. But I'm not enough of a developer to know how feasible that is. So maybe it's just I have a particularly complex problem to solve. Ondrej's given a few examples of how it is quite complex. So.
And then lastly, that config edition that's now new in Java 8.
Yes.
You mentioned that there's 3 ways to actually implementation of properties file.
Yes, the microprofile config, yes.
Yeah. How difficult or how possible is it to write your own property reader implementation? What you mentioned because
Yes. Yep, it is very possible. So this was something that I nearly did with a demo, but I thought that if I did do it, then maybe I'd run out of time, ironically. So yeah, we're basically discussing this in the office. So the use case that I've got here is that we don't know this URL for this microservice ahead of time, so we need to kind of at runtime discover it. But then the remote microservice, that may also not know its thing ahead of time. So really what we need to do is have the remote one to kind of set a property in some config source. Now, there's a company called, I think, Config Hub, which do like a server which can, you can set and get properties from. So the config API was deliberately, I'll let Ondrej talk a bit in a minute, because he helped to specify it all. There was a very deliberate decision made to avoid doing that. So they wanted it to be read-only, specifically to avoid things being set. So it is possible to do this. So you kind of, to set a config property dynamically through code, what you'd need to do is create your own config source, correct? And then set that in that way using the SPI that's available. So the reason why I didn't want to do that is because it's moving outside of the scope of configuration of an application and into being a service registry, effectively. So, like etcd or some other one that I've just forgotten, any others, console maybe. And it seemed too far outside the bounds of what config really was. So I don't know if do you want to correct what I've just said?
I'm not sure if I correct, but maybe add what you didn't say. Simply, the configuration API, which is part of MicroProfile, has 2 different components. One is for reading the configuration, and this provides 2 different APIs, just for plain Java API with static methods and with CDI annotations so that you can inject values. But it also has an extension or SPI interfaces. And you can provide your own configuration sources within your application. So you're just implementing an interface which has, I think, 4 methods. One of them is get value, which gets the name of the key, and you provide the value from this object. And the configuration mechanism detects this your implementation of config source via service locator. So we need to create an additional service file to register this implementation. And the configuration it's not a specification in terms of JSR, but the configuration mechanism specifies ordering of these sources. So there are defaults or config sources for providing values from system properties, from environment variables, and they have some value of order or some index to order these config sources. Yes, you can chain them. You can chain them back. Basically, the sources with a higher order are asked first, and if the value is not there, the other sources are asked until it's found. So you can provide a config source with higher order, high priority, and you can override any value there, and it's still within your application. You just register it with the service locator mechanism with a service file, and what the configuration does, it will detect the config source, it will ask it for the value, and it will provide it then when it's required by the application. Yeah?
Yes? Okay, it's a really brand new feature that. So actually, the demo that I was going to run.
What was the question?
Oh yes, sorry, I should have repeated.
Was the question to get it right about which server or which node in the cluster is the master? Is that correct? The thing is that the advantage of Hazelcast, that's why I said it's very complex and you wouldn't want to write it. It's a distributed memory or distributed data cluster. So it doesn't have a notion of a master. You just connect to it from a node or even from a client which is not part of the cluster, and you can send the data there, and it's evenly distributed across the cluster. Hazelcast supports data distribution and replication. So I think by default it copies the data 3 times, so that it's always at least on 3 nodes. And when any node goes down, it's redistributed, so that it's again on 3 different nodes. So it's always there, and there is no single point of failure with Hazelcast. You can bring down any nodes. If there is at least one node, the data is there, if you have enough memory on the node to store the data. So it's just enough to to send the data from a node, and it's distributed, and then there's no master. It's always available. If the data is not available on the node, Hazelcast will ask other nodes to bring the data from them.
Yeah, as I say, it is a brand new feature, so it's not even released yet. I think depending on how testing goes.
The configuration is released.
This is the cluster, clustered.
Oh
Singleton.
yeah, the cluster Singleton.
Yes, yeah. So obviously the way that I'd got it in my demo, you kind of start at multiple of these StockTicker Uber jars. They've all got the application in. If there's already one running that's running this Singleton, then it just doesn't start the EJB timer, and then obviously waits for one to go down. And I guess however the partitions are set up, so no, it kind of designates one node as like the primary copy of the data, and then like backups around it. I don't know how it would decide which backup to reinitialize, but then that's how it would work. So yeah, at the moment, I think it's just EJBs that it works on. But yeah, I say we. The engineer that's doing it is working on the CDI beans as well.
Initially, I was answering a different question. I thought you were asking about the config source, which is also based on Hazelcast with the cluster config source we have in Payara Micro and Payara Server, is that you can send or provide a config source from one of your applications into, or send the configuration to the cluster from one of your nodes, and then it's available to all the nodes because it's evenly distributed. With this cluster scoped being, it's more complex because you need to synchronize and make sure that the data is only once there. And Hazelcast also provides locking mechanisms and synchronization primitives. So we only needed to put all these things together to provide things for the Java EE API, because Hazelcast is not it doesn't know about Java EE. So what we essentially want to do and what we are doing in Payara is bringing all these excellent features of Hazelcast to the level where it can be easily accessed from Java EE applications. It's the same with CDI Event Bus. We are using Hazelcast topics and Hazelcast queues to distribute the data, but the API is very simple. It's just 2 qualifiers. And it's the same with the CDI scope. It's just one scope annotation, and it provides these things based on Hazelcast and synchronization.
Okay. Any other questions? No? All right then. Well, thanks again for bearing with us. We got through it, just about. Yeah, I think we've actually got a demo that's sort of similar to this on the Payara stand in the exhibition hall. So if you want to kind of come and see something that's actually uses Raspberry Pis as well, do drop by. Thanks.